So in this video, I want to give some general advice for taking linear algebra. So here are some tips for linear algebra. And this is mainly addressed to students who are not math majors, right? So they're taking the linear algebra that's typically given. It's usually taught in the math department, but the main audience is going to be engineering students or computer science students mainly, maybe some math majors, maybe some kind of non-STEM majors, but usually, like 90% of the students taking linear algebra in these classes are going to be engineering students, maybe pre-majors, maybe majors, and computer science. And usually the classes that they've taken before, so before linear algebra, they've taken calculus, usually Calc 1 and Calc 2, maybe Calc 3, maybe not. Most of the students who are taking this class have seen vectors before in previous classes, so maybe they learned about vectors in high school physics. They might have seen this if they had taken multivariable calculus, and so that's sort of the typical audience for this class. So this is mainly addressed to students who are in that situation. So linear algebra is like a really different subject than calculus. And the way you go about learning this subject might also be different. So in previous math classes, you might have done a lot of computations and a lot of applying theorems. So it might be, do this integral, do that integral, right? Find this derivative, find that derivative, and so on. And it's a lot of applying formulas and applying theorems. Right, so you might learn the chain rule when you have a composition of functions. You do this to find the derivative, and so on. And in linear algebra, things are different, and there's a lot of vocabulary, and you're kind of building things from the ground up. And in order to do that, you have to practice using the vocabulary. And so, well, before I get into specific linear algebra tips, let's just talk about kind of just general tips that will help just when you're taking math classes. But these tips are really just more general than that. It's probably helpful for any class you take. So, well, the first one is to go to class. Okay, you might think that's a no-brainer, but there are a lot of students who don't go to class. I mean, there are a lot of students who just, they show up on the first day, and then they show up on the test, but in between, they're just not there. Don't do that. Go to class. I mean, I think one downside of the pandemic is that a lot of students have gotten used to taking online classes or doing everything online. And so once things have kind of gone back to in-person classes, that transition hasn't been made. Like a lot of students are still used to not going to class, like not going to, an in-person class. And so they're just used to never going to class, and then they just don't go to class. Once, people are in that transition where it's kind of going back more to in-person classes. So, if you're taking an online class, right, or a class where all the videos are uploaded and are recorded and so on, then okay. But, if students don't show up to class, then there's just not going to be a class, right, if it's an in-person class. So it really is important to go to class. And you're missing out if you don't go to class. So make every effort to go to class. Of course, stay home if you're sick, but other than that, you are expected to go to class. I mean, that's just part of the course. And, if you are concerned about coronavirus, and that's valid, that's that's something maybe you could talk to your professor about, right? Like, you know, and see what they say. Okay. So then, so, you know, you're probably going to get lost at some point, right? I mean, the vast majority of students who are taking linear algebra haven't taken this class before and struggle because it's a lot of new content. I mean, like everything in this class is new. And so it makes sense that, you know, it takes time to really understand things because it's so new. But, you know, what do you do when you get stuck or want some help? Well, you know, it's a good idea to go to office hours, right? So go to office hours, and if there's a TA in this class, see a TA, or take advantage of any math help centers. Usually the university will have some sort of math center or something where you can go, and then there will be an undergraduate. Usually an undergraduate who did well in the class that you're taking, they'll apply to work in the study center. They get paid a little bit of money, and they also help students who are struggling in the class. So that could be a useful thing to take advantage of, you know. But the point I'm making is that you shouldn't feel that you have to figure all this stuff out on your own. I mean, there are resources to help you. And one thing that a lot of students do is when they're stuck, they'll look things up on YouTube. Okay, so I have a lot to say about that, and that could be helpful. But what I would say is that most of the time, like 9 times out of 10, it's better to just talk to an actual person, right? It's better to talk to someone who's familiar with the class you're taking, especially since there are a lot of different ways to teach linear algebra. Not all linear algebra classes are the same. And so if you're just watching like a generic video, right, the person who made that video isn't going to know your exact situation. So, yeah, I recommend, I think it's okay to look at videos. I mean, you should also keep in mind that a lot of videos have mistakes in them. I mean, I've looked up linear algebra videos kind of just to see what's out there, and there are a lot of mistakes in them, right? They're not edited very carefully. They're not necessarily fact-checked for accuracy and so on. So, so yeah, and some of the things that people say in these videos are just flat out wrong. I mean, sometimes people who make these videos aren't fully qualified, unfortunately, to teach linear algebra. And that's unfortunate, but that's kind of just the way it is. And so you just have to watch out. I mean, just in general. I mean, of course, there's a lot of garbage online, but you know, even math, you know, there are a lot of things that are just not correct, and so, you know, you just have to make sure that you watch out for that. And also, it just takes up so much extra time. I mean, you know, you could spend like an hour just looking stuff up online when you can get the question answered in like 5 minutes by talking to someone. So it's just so much more efficient to just talk to someone. Okay. So don't hesitate to go to your office hours. Don't hesitate to ask your instructor questions. Most of the time, in my experience, you know, your math professor will be happy to help you. If your professor I think one reason why a lot of students don't go to office hours is because they're afraid of looking stupid. But actually, it's usually even worse if you're having difficulty, but then you don't make any effort to see the instructor. You know, that's not gonna, your professor's not gonna think highly of you. If you're struggling in the class and you make no effort to actually talk to them. Okay, so go to office hours. Okay. And take advantage of these things. I mean, office hours are great, especially if you have a quick question, but if it's kind of clear that there are a lot of things that you're really, really lost on, then office hours might not be the best, right? Because your instructor might not feel like explaining everything kind of all over again from scratch, right? They might say, okay, go back to your notes, review a bit. That's a sign that you have a lot to work on, typically, and in that case, it really is better to just go back to your notes, maybe talk through your notes with someone. So if you have notes that you're trying to understand and you don't understand, it's a good idea to talk through them with a TA or someone at the Math Help Center to kind of get you back on track. Okay, and that leads me to number 3, which is to make sure you review your notes. Review your notes after class, because you don't want to just take notes and then call it a day. I mean, you want to take notes and actually review them and make sure you understand them. And if there's something that you don't understand, then just put a little check mark or something, or a question mark in pencil, and then as soon as you can, ask about them to your professor or a TA or someone at the Math Help Center. Okay, so those are just general pieces of advice, and of course you want to do things like take practice tests and so on. That's really important for preparing for a test, is to take practice tests, and also you want to look at the textbook and look at examples in the textbook and try to understand those examples. Okay, so maybe I'll just leave that as number 5. So read, worked, examples. Maybe before you start the homework, right? So like, let's say you have a homework assignment and it's like a bunch of questions. Then it might be a good idea to kind of read those questions first, just to kind of have an idea of what's on the homework. And then take a look at your notes and your textbook for fully worked examples. Examples that have the problem and all the steps and the solution, and make sure you understand that first. Because oftentimes, when a student doesn't understand a homework problem, there's usually some example that the instructor did in class, or an example that's in the book that's like relevant, that explains kind of the general procedure, and a lot of students won't understand that example, even the example that has all the steps explained. So make sure you look for those examples where they explain all the steps, and make sure you understand those steps, right? Ask yourself, okay, what would happen if you change the numbers a bit, and so on. And that's where, because sometimes books can be really hard to understand, it may help to actually talk to a TA or someone in the Math Help Center. So you could say, hey, I'm trying to understand this example in the book. I have a question about it. Can you explain? Right? I mean, that's a really good question, especially since often the textbooks, for the purpose of keeping the explanation streamlined, they'll skip some steps. So those are general math tips. Okay, now let's talk about the specific, so linear algebra specific advice. So one thing that this class has is there are a lot of definitions. So one big piece of advice I have is to memorize the definitions. Like the dictionary, you need to know this stuff cold. These are things that you need to know cold. The dictionary definitions. So not just have a vague idea of what these things are, but to be able to kind of just recite the dictionary definition. So a good example would be, okay, let's just look at an example. Let's say that you have the term linear transformation. Let's say you're in class and your professor says, okay, I'm going to go over linear transformations. Typically, they'll write the definition of linear transformation on the board. And you should memorize this. You should memorize the dictionary definition. So I can tell you what it is. It's a function t from one vector space to another, such that for all v1 and v2 in V, right, T of v1 plus v2 is T of v1 plus T of v2. And T of CV equals C times T of V for all scalars C and all vectors V. And that's the definition. And see, I was just able to tell you the dictionary definition off the top of my head. And you should be able to do that too. Another example would be, you know, an eigenvector or a basis, right? An eigenvector is a vector. An eigenvector for a matrix A is a vector V such that A times V is lambda times V for some scalar lambda. And the basis for a subspace or basis of a vector space is a set of vectors in the vector space that spans the space and that's linearly independent. And you know, to understand what that means, you have to know what span means and you have to know what linear independent means, right? So a set of vectors is linearly independent if, let's say that the vectors are v1 through vk, they're linearly independent if the equation c1 v1 plus dot 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 plus ck vk equals 0, the 0 vector implies that c1 is 0 and c2 is 0, all the ci's are 0. That's what linearly independent means. Right? So notice that I didn't have to look any of that up. I just remember all this. So, you know, you might have to be intentional about this, and it might not just happen automatically, that you just remember the definition. So whenever you see a definition, you know, take a moment and try to memorize the definition. That's a general piece of advice. Okay. And another piece of advice is, okay, I want to keep this video somewhat short, so maybe a few more tips. But one piece of advice is to rephrase. Let's say you're given some problem to do, some homework problem. Rephrase the question in terms rephrase the question in a way that you actually understand what's asking, right? Rephrase the question in a simpler way. You know, a lot of the difficulty sometimes is even just knowing how to start. And in calculus classes, I think a lot of students are used to just executing the procedure, right? It's like, okay, when I have this question, what do I do? What's the procedure? And then they'll kind of autopilot and do it. And that might work. You know, that might have actually worked when they took calculus. But that doesn't work in this class. I mean, if you ask something like, is a vector in the span of these other vectors, right? Notice that they use the technical vocabulary word span. So before you think about, okay, what do I do? You know, just take a moment, just pause and ask yourself, okay, what is this even asking me? Like, how can I rephrase this question without using the word span? And then you'll say, okay, what it's asking me is this vector a linear combination of these other vectors? Okay, well, what does that mean? You know, and when you write that out, you'll see that that really boils down to asking, does a certain system of linear equations have a solution? Right? And then once you understand that, then you can use the facts you know about solving systems of linear equations to answer the question. So, you see, if you think about what we just did, we started with a question, right, about span, and then we thought about what that question's asking you. And then once you figure out what that question's asking you, oh, it's asking me about whether a certain system of linear equations has a solution, and you know how to do that, then that will guide you in how you solve the problem, right? It's like what you do to answer the question is based on what the question's asking you, right? So those are some of the things that you may have to get used to doing in linear algebra that you might not be used to in previous math classes. Okay, thanks.